So my name is Divya Oberoi. I work at a place called the National Center for Radio Astrophysics. It's located in Pune in India. And I've been associated with the MWA project since before it became the MWA project. And my area of specialization is solar radio physics. So the evolution of the MWA project, it grew from a somewhat larger collaboration, and circumstances forced us to sort of make a smaller collaboration and build a more focused project. And that is what became to be known as the MWA. The MWA has had a very profound effect on my career. In fact, almost exclusively the science which I have done in the past 15 years or so has been with the MWA. So talking about the achievements of MWA, the MWA came around at a time when, the design of the telescopes, the radio interferometric telescopes, was evolving such that new telescopes which were being built to gather sufficient amount of data instantaneously and over very narrow frequency channels that you could make excellent images over short time and frequency intervals. And so all of the science which, all of the solar radio science which it has enabled really flows from this particular property of the telescope to be able to make really fantastic images over very short time intervals and over very narrow frequency intervals. Looking back briefly for a minute, so what we were writing in our funding proposals, in the early days of MWA is actually now coming to fruition as far as the solar radio physics is concerned. And as we do that, we realize that we are still only scratching the surface. So we do have, really tantalizing evidence for some of these things happening, but there is a whole lot more to be done. And as it happens in science, you answer one question and you raise a few more, right? So that is the phase in which we are. But I believe we are at a place where we are at a cusp, where we are going to make pretty rapid progress in the times to come in answering some of the most pressing questions we have about solar radio physics. These are related to coronal heating. Why is the solar corona, at a couple of million Kelvin, even when the photosphere is only at some 7,000 Kelvin or so? And also about how does the sun manage to accelerate particles to such high energies, which give rise to all sorts of phenomena for space weather, so that it's going to have really big societal impact as we answer these questions. Solar radio physics has been a very tiny community worldwide. And a lot of that has been because there was never a radio telescope which was a good match to the problems of solar radio physics, right? The sun is a very challenging source to image. It changes very quickly in time, in frequency. The brightness of things varies dramatically across different events. But now we do have a good match to these imaging challenges in the MWA. And I'm hoping that the work which we are doing, the data which we have gathered, is going to inspire a whole lot of other people to join us in this journey and understand our sun better.